Hello, welcome. This is an Excel further pure one topic video. This is on solving cubic equations in terms of finding the roots of a cubic equation. Now you may go, oh, that's ridiculously easy, we've done that before. But obviously this is further maths and we're in the idea of complex numbers. So we're going to be introducing complex numbers to cubic equations. Now, as I said, you may go, oh, cubic equations, we've done that, that's easy, that's C1 stuff, or C2, get out there. Okay, so the most familiar type of cubic equations that you will be used to is either one of these. So, obviously you've got your negative and positive cubics, that's a given. But you may either get a simple cubic, that is something like this, that just goes through the centre, or you may have a more complex cubic, something like this, where you have a sort of a double knot in it, so to speak. So you have two peaks and three intercepts. Now these three intercepts are roots, and because these are in whatever equations cubic will be, they are real numbers. Now you may get a cubic that looks something like this. Forgive my terrible sketching. Where it's something like this. So yes, there are technically a root here and technically a root here, take a root sort of turning point sort of thing, but there's only one real root, and what we mean by this is there's two imaginary roots that would be roots if this was a moved up or whatever it might be, because this is the bottom of a cubic but it doesn't actually intercept anywhere. So when we had a quadratic, so this is part of this, so if you can imagine this as, you would have a root of a quadratic that doesn't factorise, you would have a negative discriminant, or that would lead us to do what we did before, where we had a root which, if you have a complex number of it as a root of a quadratic, then it will be a complex conjugate pair. As I said, that was explained in the last video. So what you can either have, just to summarise this, you can either have three real roots as shown here, or you can have two imaginary roots and one real root. Okay, so what I mean by that is generally, you may have seen this as kind of related to what you've done before. You may have seen something like x take a brackets bx squared plus cx plus d equals 0, or you have a factor and a quadratic, and you could say, oh well, this quadratic doesn't factorise, so we leave it as that. Well, technically it does factorise, but there is no discriminant, so we can't factorise it, or a negative discriminant. Okay, so what we mean by that is then this is a quadratic which would give us a complex conjugate root. So what we would do to solve that is use the quadratic formula and come up with a complex conjugate pair. However, the exam's not going to be that nice to you. We need to understand how we get this root if we're not given it in this situation. If this is what you want to see it as, and then this proves that we've got a real root here, which might be this one, and we've got this quadratic, which when used in the quadratic formula gives us these two imaginary roots. But how do we get to that stage? Okay, so I might have done it the wrong way around, but who cares? I don't. Well, we know this is a factor, so we have to relate it to our C2 knowledge of factor theorems. If you haven't done that, you check that out. What that essentially says is when x take a is a factor, then f of a will equal 0. So what this basically means is if x take 2 is a factor of this cubic, because obviously that will give us a cubic, such as x cubed plus x squared plus x plus c equals 0, something like that. Obviously it might not be as simple as that, but you might have 3x cubed, etc. But what I'm saying is, if x take 2 is a factor of that, when you put 2 into this, you would get 0. Okay. So let's sort of summarise this in quite a nice way that we can actually be able to do something with it. Okay, so just get rid of this bit of information on the board here. So hopefully you can see how we've got to that. So if we have an equation, let me find the question. If we're told okay, so there's a couple of ways that the exam might give you this. So in terms of finding out this factor, there are a couple of ways that you would be expected to do it in the exam. So I'll just show you now. Now the first one is the easiest. They will say x equals 2 is a factor. And now that is straight away saying, okay, well f of 2 must equal 0, because that says x take 2 is a factor, because x take 2 would equal 0 in this equation that I'm about to tell you. But they've just gone ahead and straight, they might say x take 2 is a factor, and you'd have to realise, well, x equals 2 is a factor. So therefore f of 2 must equal 0, as I try to explain over here. Okay, so it looks something like this. But the equation that you get given for this question is x cubed take 6x squared plus 21x take 26 equals 0. Now, if you were told this is the other method. Oh, I kind of can actually. No, we'll do this. Oh, shut up. So you might be told that x take 2 is a factor, so therefore x equals 2, and f of 2 is 0. So just to double check this, you might want to put f of 2, so that equals 2 cubed, which is obviously 8, take 6 times 2 squared, which is take away 6 times 4, which is obviously 24, plus 21 times 2, take 26. And if you would sub that in your calculator, so you would get f of 2 equal to 0, as the exam proves, but you should just take that as a given. Okay, so we know f of 2 is 0, and x take 2 is a factor. Now if x equals 2, then x take 2 must equal 0. And as we said, x take a equals 0. So therefore x take 2 must be a factor of this x cubed take 6x squared plus 21x take 26. So what we do then, if you think again, it's the factor theorem, remainder theorem kind of area of C2. If x take 2 is a factor of this, and we need to find the other factors to put it in this kind of form where this is the x take 2 part, and we want this other quadratic, then we need to put x take 2 here. And we use the remainder theorem, because the remainder theorem says basically if you've got a factor, you divide the original equation by something you know is a factor, which is x take 2, then you should get no remainder. So, I mean, obviously it's going to come out to be no remainder, that's a given, because we've just checked it is a factor, so it is obviously going to give us a remainder. But the quotient is going to be a quadratic, because when you divide a cubic by a linear function, you will get a quadratic. So, if we follow that idea, because we want a quadratic, because that's the other factor, so x cubed takes 6x squared plus 21x take 26. Okay, so you divide x cubed by x, that obviously gives you x squared, times x take 2 by x squared, so obviously gives you x cubed take 2x squared. Do the standard thing of taking it away, and obviously that's not going to get rid of it completely. It gets rid of the x cubes, and then you take away negative 2x squared, so you're adding 2x squared, but it gives you negative 4x squared plus 21x take 26. Okay, so then you do the same method, so negative 4x squared over 4x, or what would you have to do to x to get negative 4x squared, and that's obviously times it by negative 4x, so that's the next part of the quadratic, times x take 2 by negative 4x, obviously gets you negative 4x squared, negative 4x times 2 is plus 8x. Okay, and you take that all away, so double negative, so the x squareds cancel, and this obviously gets you then 13x take 26. Okay, the next part then, obviously if you were to take that all away, as I said, you would end up with 13x take 26. So x take 2, 13x take 26 divided by x take 2. Then that obviously gets you 13x over x is plus 13, so that's the final part of the quadratic. And that obviously gets you there 13x take 26. When you times x, take 2 by 13, and obviously that cancels to give you 0. Okay, so that's just basic algebraic line division. If you didn't get how I did that, please refer to my C2 video on that, but I want to keep it in the realms of the further maths part. Okay, so, I mean, if that didn't come to 0, then you've done something wrong with your quadratic. So it's kind of a nice way of saying if you've done something wrong. Now, this obviously doesn't factorise because we're in AS further maths. But if you were in C2, then you would factorise that and get 3 factors for your quadratic. But you could try and factorise that, but there's no 2 numbers that you could put into x bracket x. And 2 numbers that are missing in that double bracket situation there to make x squared take 4x plus 13 when you expand the same double brackets. So what we have to do is write it in this form. So x take 8 and then the quadratic. So I'm just going to do that under here so you can see the comparison. So obviously we said that x equals 2 is a factor. So therefore x take 2 equals 0. So we put it in this kind of form. So x take 2 brackets x squared take 4x plus 13. Now we could have easily wrote 1x squared there, but we don't generally do that. Okay. Now, obviously this isn't going to factorise. So there are a couple of things that we can do when we try and factorise quadratics that don't simply just put into a double bracket situation nicely for us. We use completing the square, or the one I'm going to use now is the quadratic formula. So it's negative b, which is negative 4, so that's just obviously plus 4, plus or minus the square root of b squared take 4ac, so that's 16 take 4 times 1 times 13. Obviously that gives a negative answer. Over 2a, which is just 2, and just remember to put that equal to x. So therefore this gets you x is equal to plus 4 over, plus or minus the square root of minus 16, because 16 take 4 times 1 times 13. So that is 16 take, sorry, one sec, let me double check, I'm not going absolutely insane. 4 times 1 times 3. So 16 take 52. So that's, sorry, negative 36, negative root 36. Now, if you were to just take out negative root 1, so negative 36 is equal to negative root 1 times root 36, that's 6i, over 2, so you cancel that down to get 2 plus or minus 3i. Okay, so it's just essentially, so in the quadratic video that we did before, we were given them 2 factors and asked to work out the quadratic. So you could work backwards if you wanted to double check that you were right, but I'm assuming you would be. Okay. So that's essentially how this works. Now I assume I totally understand I've not done the best explanation at that. Okay, so what I'm going to do is I'm going to go straight through that again, but this time I'm not going to assume that we're told what a factor is, and because you might not always be told what this factor is, they probably won't be that kind in the exam. Okay, so let's imagine that we didn't know what this factor was. What could we possibly do? So if we didn't know what x take 2 was, what could we possibly do to work out what it was? So the other way that we were going to go through this is essentially if we didn't know the other factor. So as I said, we knew in this case that it was x take 2, but now obviously you can see I've rubbed this off because we're going to assume we didn't know that. So obviously this is, I've sort of narrowed essentially down what the working out was here into a very short format. So I hope you can understand how we did that. So what I'm going to do is, obviously, assuming this is all we've got, so the equation, and we're asked to factorise it. Now, obviously, you wouldn't be able to do anything other than this, and you shouldn't think of. Okay, so assuming we don't know the factor. Now, the factors of this equation, well, one of them is obviously going to be real, and well, one of them is all these factors are going to make this equal to 0, as was stated. But the thing to focus on is this minus 26. So the factors are going to have to, because if you go back to the days of the quadratics, because essentially what this is going to become, then we need to think, well, obviously something that's going to be a factor of 26, as we can see here, is obviously going to be a factor of 13. But ignoring that, we need to think of a couple of factors that are of 26. Now the obvious ones are 1 and 2, and you can obviously have plus or minus either one of those. And obviously 2, obviously we can use that, sorry, because it's an even number, so we can use 2 for that. So you can use the positive version of it or the negative version of it. So what I'm going to do is I'm going to do the positive version. So when I say the positive version, we're just going to assume what x could be and put the positive or negative version of 1 or 2. So it's sort of like a polynomial thing. So the first thing we're going to do is f of 1. So we'll sub 1 into the equation for x. So 1 cubed take 6 times 1 squared plus 21 times 1 take 26. And if you were to work that out, it is not equal to 0. So let's sub f of minus 1 in there. So minus 1 cubed takes 6 times minus 1 squared plus 21 times minus 1 take 26, and you will again find that it's not equal to 0. And if you continue doing this, so f of 2, you would get that not equal to 0. Sorry, f of minus 2, you would not get that equal to 0. But if you were to put f of 2 in, then you would get that as equal to 0. So therefore, you know that x take 2 is a factor if f of 2 is 0. Okay, so as I said, if they don't work, then you start having to think of other factors. So if that was 15 per se, then you would try 5 and 3. If 1 didn't work, you obviously wouldn't try 2, because that wouldn't be a factor. Okay, so assuming that is standard 1x cubed. And then you would follow the same method that we've done before. So then you would divide the original equation by x take 2, and you would end up with what we just finished off with there. Okay, so that's just a summary of this topic. There is one more question that I want to do with you actually. So what I'm going to do is I'm going to go back again and kind of rub all this rubbish information off the board, and then we can sort of continue on to the next kind of question. So just going to pick out another question, and then we can go over that.